So now this one is W18QP23, and he says complete the table to show what you observe when an aqueous solution of glycolic acid is added separately to each of the reagents. If a reaction occurs, state the functional group of glycolic acid that is responsible. So this glycolic acid has two specific functional groups. It's got a carboxylic acid and it's got a primary alcohol. So carbonates, it's going to react with carbonates. Why? Because carbonates react with acids. So observation, whenever an acid reacts with a carbonate, it is going to produce, whenever an acid reacts with a carbonate, it produces salt, water, and carbon dioxide. So bubbles of carbon dioxide or effervescence are going to be seen. So you're gonna see effervescence or bubbles are going to be observed. So does a reaction occur? Obviously it does occur. Which functional group? It's the carboxylic acid functional group. And then you have 2,4-DNPH. What is 2,4-DNPH? There's not going to be any reaction with 2,4-DNPH. What is 2,4-DNPH? It was this thing. Okay, it was a test for identifying, right in this corner over here, it was a test. One second. I said it's a test for identifying ketones and aldehydes. Both of them had a positive test with 2,4-DNPH. You got an orange precipitate when you added 2,4-DNPH, but it's a test for ketones and aldehydes. This molecule over here is a carboxylic acid or an alcohol. It's not a ketone or aldehyde, so no reaction occurs, nothing happens. And dichromate 6, acidified dichromate 6, that is an oxidizing agent, and you have a primary alcohol on this side. So primary alcohols, they get oxidized to carboxylic acid. Primary alcohols, they turn into aldehydes first, and aldehydes, they further get oxidized by K2Cl2O7 to form carboxylic acid. So there's definitely going to be a reaction. And whenever you have potassium dichromate 6, the color change is orange. It's orange to green. Or does a reaction occur? Obviously, it does state the functional group involved. It's the primary alcohol. The OH.
Sir, what does the acid oxidize to?
The alcohol is the one that's going to get oxidized.
Yeah.
Okay. Carboxylic acids don't undergo any further oxidation.
Yeah, I didn't see that there was alcohol. Yeah, okay, now.
There's this primary alcohol. So basically, it's going to get oxidized. The primary alcohol will also turn into a carboxylic acid. So this side will also turn into, एक side to pehli carboxylic acid thi, the right side. Now the left side would also turn into a carboxylic acid. Anyway, so two reaction sequences to make glycolic acid are shown. Draw the structure of X. So what you're seeing over here is you've got an aldehyde, and it's reacting with, it's forming a cyanohydrin, HCN and NaCN. So if you look at the chart, where's the aldehyde? Both aldehydes and ketones, they have this, aldehydes and ketones both, any carbonyl group. They react with an HCN, NaCN catalyst. It's a nucleophilic addition reaction. And what happens is the C double bond O over here, it turns into COH and a CN. This is what happens. So given yoga mechanism as well. You need to know the mechanism as well. This is the mechanism. Like whenever you have a carbonyl group, the CN-1, it attacks the carbon, attaches to that carbon with double bond electrons. They get repelled, and they then grab one of the H+1 from HCN, and they bond with it to form the alcohol. So this is the reaction sequence that's going to happen over here. So X is going to be, okay, you have an aldehyde HC double bond O and H. This is this thing. This carbon is positive. The CN-1 is going to get attached to the carbon. and the top one will become OH. So that is what X is. Draw the structure of X. And name the region for reaction number 2. So reaction number 2 is you go from this point to this point and then you reach this point. So reaction number 2 is the OH is still there. The CN turns into a carboxylic acid. So that is hydrolysis, which is this one. You're going to have a nitrile and you reflux it with dilute acid. It eventually hydrolyzes to form carboxylic acid. So this is what's going to happen. So reaction number 2 is hydrolysis, dilute acid or H2SO4 plus there's going to be reflux. Or name the mechanism of reaction number 3. So reaction number 3 is, what is reaction number 3? Nothing happens to the carboxylic acid. Bromine gets added to the carbon chain. What is that? Oh, when a halogen gets substituted into the carbon chain.
Free radical substitution.
Okay, so that is free radical substitution. That's this one over here. Okay, this one. Any alkyl chain, any carbon chain, you get Cl and Brs, a halogenoalkane is produced, and the mechanism for that reaction is radicals get produced, and then those radicals, they steal away hydrogen atoms from the carbon chain. That makes it a radical, and that radical then grabs Cls from somewhere. And as a result, the H gets substituted by Cl. So that's this. Draw the structure of X so you can he's the name the mechanism, that's free radical substitution, and essential conditions would be UV light. So it's going to be free radical it's going to be free radical substitution, and UV light would be required. And he's asking for the Sn2 reaction number 4. What's reaction number 4? The Br gets substituted by OH. So the Br over here gets substituted by OH. That is nucleophilic substitution. That is this one. Okay, you have, if you have a halogenoalkane, you add the OH nucleophile and it will substitute the halogen. And the mechanism is, he's asking you to write the Sn2 mechanism. The Sn2 mechanism is for a primary halogenoalkane. The OH-1 comes and attacks the carbon, which is already polar, and which is why the OH-1 is attracted to it, and the Cl gets knocked out. So that is a Sn2 mechanism. So he's asking you to draw in this part, he's asking you to draw so this is a primary halogenoalkane. The carbon is only bonded to one carbon chain. So what's going to happen? The OH nucleophile, this carbon has a positive charge, the Br has a slight negative charge. The OH is going to be attracted, and at the same time, the electrons of Br are going to be repelled. So there's going to be substitution that is going to take place. Here, agla part hai ki glycolic acid can also be made by reacting this with NaBH4. Now, NaBH4 is a reducing agent. Okay, what happens? The aldehyde turns back into an alcohol. The carboxylic acid, LiNH4, turns back to an aldehyde. The ketones also turn back into an alcohol with NaBH4. I mean, the reverse, which is shown over here. So he's talking about the reverse. So you've got a carboxylic acid, and he's saying that now carboxylic acid are reduced by LiNH4, not by NaBH4. They need a stronger reducing agent. So only ketones and aldehydes are going to get reduced. So what is going to happen is, the first thing is it's a reducing agent. They already gave you the reaction. So it's a reducing agent, and the other one is write down the reaction and use H to represent NaBH4. So the reaction is, this one is CHO. You can remember the aldehyde is always written not as COH but CHO. and this side is COOH, and the other side is CH2OH, and the right side is carboxylic acid. So we're talking about reduction here. So the reducing agent is represented by H. So the amount of oxygens kind of stay the same. It's exactly the same amount of oxygen. The only thing that's getting added is you had 2 hydrogens and now you have 4 of them. So it's going to be 2H. And that's about it. Abhi aage, the infrared spectrum, it says that there is so this one. He says that there is glycolic acid, which was CH2OH, COH. I mean, it's this molecule. It's 2 carbon atoms. It's got a carboxylic acid on one side, and it's got NOH group on the other side. Now, nothing, so it's reacting with itself. Sulfuric acid is the catalyst, and a new compound Y is produced. Now, remember this. You have a carboxylic acid group, you have an alcohol group. So 2 molecules are reacting with each other. So if I draw another molecule, so it's got carboxylic acid on one side and CH2OH on the other side. Now, the acid group and the alcohol group, they will tend to react together, and they're going to produce an ester. The OH would be lost and the H would be lost from the alcohol. And the 2 groups would kind of join up to form an ester link. Is that clear? Is this clear?
Yes, sir.
Achha, so basically it's 2 molecules that are reacting with each other, and the other side could do the same. The alcohol loses the H and the carboxylic acid loses the OH. And they would also join up, and that's going to be an ester link. So the best case scenario is that is C4. O is also 4, H is also 4. So that is exactly this thing. It's Y. And you can confirm this by the infrared spectrum. What does the infrared spectrum tell you? The infrared spectrum tells you you need to have the data booklet with you. So that's the infrared spectrum. Now, the most unique bonds that can be easily identified are the sedal bond, because they have a strong absorption in the 1600-1700 range, which in this case you do have one. So there's a strong absorption. So that kind of indicates that it's got a C double bond O group. So you do have a sedal bond O group, which is over here. And then you can see there's another strong absorption below 3000. The other bond that can be easily identified from the infrared spectrum is the OH bond. So 2500 to 3000, we do have an absorption, but it's got to be strong and very broad. Our absorption is not strong. It's strong, but it's not very broad. So this absorption is not broad. It's kind of a sharp absorption. So that kind of means, or it implies that there's definitely no OH that belongs to carboxylic acid. And that is also true because our molecule does not have an OH. It has no OH that belongs to carboxylic acid. Uske baad ye ke the alcohols, the other normal alcohols, that can't be true as well because they resonate. So they vibrate at a much higher frequency. So there is no OH to begin with, which so state how the spectrum differs from an infrared spectrum of glycolic. So anyways, the question wasn't about that. This is the infrared spectrum of this molecule over here. Okay, so how would it differ from this one? The way it's going to differ is, firstly, this molecule over here has OH groups. So there's going to be, one major difference would be between these two molecules. It's got an OH group. And it's got both types of OH. It's got a primary alcohol, it's got a carboxylic acid OH as well. So you're going to write that you're going to get this absorption in the 2500 to 3000 range. It's going to be strong and it's going to be very broad. And you're also going to get an absorption above 3200 to 3600 range. That would belong to an alcohol. And it's going to be strong. Now, in this case, again, there is no absorption in the 3200 range. So that is how it's going to differ. This one would differ. That's the main difference. Clear? This one has OH, and this one does not have OH. So absorptions belonging to OH would appear over here. Absorptions belonging to OH will not appear on the other side. That's okay. Next is we did draw the structure of Y. So let's move to the next, the previous one. Which is this? It's a pretty long question. So the first one is, what is meant by the term high vapor pressure, which I think is no longer, that's definitely not in your course anymore. But let me just confirm very quickly. Okay, just spelling उसने use किया था. Oh, you are. Yeah, I think we don't have vapor pressure anymore. So we can, it was a simple concept. It's just the vapor. When something is evaporating, on the surface, there's going to be a lot of vapor as it is evaporating. And that vapor would be exerting a certain amount of pressure, which is why you see, like, if you have a closed bottle of water, when you open it, there's a hissing sound because there's some pressure that's built up because of the vapor that's being produced. Anyways, that's not in your course. An important reaction of CHCl3 is the manufacture of this thing. So you're given the enthalpy changes of formation. So whenever there are 3-4 ways of finding enthalpy changes. So one of the ways is that if you know the enthalpies of formation of the product, and you know the enthalpies of formation of the reactants, so what you just simply need to do is, the enthalpy of this reaction would be the enthalpies of formation of the products minus the enthalpies of formation of our reactants, which in this case is, this one is minus 482.2. Use brackets so that you don't mess up the signs. This one is HCl as minus 92.3. That's going to be multiplied by 2. Minus the reactant, which is CHCl3, that is minus 103.2. And 2HF, that is minus 273. So it's 273.3 HF times 2. That's the answer to this one. And make sure, try and do these questions. I mean, try and actually solve these questions on your calculator, because you have to be really good with your calculator. कैलकुलेट किया किसी ने? Mahad, Sidra, Osman, Muneeb, क्या है इसका आंसर?
Yes, I'm doing this. Just give me 1 sec.
Sir, minus 17.2.
कितना है?
Yes, sir.
Minus 17.2
2.
kilojoules. अच्छा ये आ गया. अब उससे अगला जो part है that is कि you've got can I explain for you the meaning of the term heterogeneous and catalyst? Catalyst means it speeds up the reaction. And how does it do that? It lowers the activation energy and provides an alternate pathway. और एक और चीज remains unchanged. And remains unchanged at the end. So that's what a catalyst is, and heterogeneous means that the catalyst and the reactants are in different phase. So they have different states. As a CHClF2 was used as an alternative for chloro. This is about CFCs. Should no longer be used because it has been found to contribute enhanced greenhouse. So, give the meaning of the term enhanced greenhouse effect. It's just meaning of the term enhanced greenhouse effect is global warming or rising temperatures. How does it do that? How does it contribute? Because it absorbs or traps heat. But it traps heat, basically it traps heat, which is why. And another associated with this one with the CFCs is that it causes ozone depletion. Let's get W18 2 3 1 second quickly. See, it's नहीं क्या था. Traps heat, greater global warming. The B part 1 क्या था? What is the question? So this one is basically looking for how does it may contribute to this effect? So it causes global warming. Greenhouse effect का क्या लिखा है उसने? What is the meaning of the term greenhouse effect? And he states that it is what it is. Even thicker layer of greenhouse gases. So enhanced greenhouse effect as compared to greenhouse effect, the only difference is that they're just saying that it just creates more greenhouse gases. That's the one more question. Or extra green or thicker layer of greenhouse gases. So that is enhanced greenhouse effect. There's a Baki ozone depletion, that was true as well. This covers sort of basics answer after that. It just means that human activity is producing extra greenhouse gases. It's the word enhanced. अच्छा और क्या था कि stated that occurs in PTFE, that's Teflon, and it's a type. Addition polymer is the only polymer that's in your AS exam. Draw the repeat unit. The repeat unit of PTFE is that it's got all of them are fluorines, and they would join up with each other. So the repeat unit would be, okay, that's going to be a repeat unit, and there would be continuation bonds, and this thing would be repeating over and over again. And so that's why it's used for cooking pans, because it's non-polar, so it is a non-stick substance, so things don't stick, food doesn't stick to it. It's thermally stable. CF bonds are strong. As a CF bonds are strong and thermally stable as well, which is why it's going to be, it's a very general question. So what? Unreactive, inert, non-polar, kind of the same thing. It was just 1 mark actually. Get the marks. Actually, they just gave you 4 lines. It's just 1 mark. And waste disposal can cause litter problems. State, ये सारी basically उसका भी मतलब है. It's state 2 other difficulties associated with disposal of PTFE. So burning produces harmful gases. And the other one is that non-biodegradable because it's got strong bonds. It's going to take a long time to decompose. Landfill sites would be required for this. So land gets wasted. अच्छा उसका कुछ रह गया था नहीं. अच्छा, what about this one? Explain why nitrogen is inert. It's inert because it's got a triple bond. Why N2 and O2 react during lightning strikes? Because lightning provides the actuation energy. I said it provides the actuation energy that is needed to break the triple bond and oxygen-oxygen double bond. Right, 2 equations to suggest how NO formed reacts further to create nitric acid. 2 equations. NO first gets, or you can spell 2 equations to suggest how NO formed reacts further to create nitric acid. So first thing is it gets oxidized in air to form NO2, and then that NO2 reacts with water to form nitrous, and inorganic and notes when are given. So mainly the B paper to sound like that. Nitrate fertilizers can cause this problems. That's this is plant life and natural. That's eutrophication. Okay, that's again an O-levels type question. Okay, there were 3-4 steps that algae grows because of excessive fertilizer, and once that happens, the sunlight gets blocked. Marine plants, they're not growing. Algae has a short lifespan, so bacteria feeds on it and grows rapidly, multiplies, and consumes all the oxygen, which is why the fish eventually end up dying. Why is calcium so why is calcium hydroxide is added to some soils? That's for reducing acidity or for increasing the pH. Or state the identity of this gas, explain why the reaction occurs. Calcium hydroxide reacts with ammonium ions. Why? Because calcium hydroxide is a base, and ammonium ions can act as an acid. They can lose H+1 ions, and this can gain H+1 ions. So the calcium ions are spectral ions. The OH ion gains H+1 to form water, and ammonium ions, they end up losing an H+1. So the explanation is that this is the explanation. The first part was identifying the gas. So this behaves as an acid, loses H+1 ions, and that gains H+1 ions. Calcium ammonium nitrate is formed when solid calcium carbonate is added to a mixture of ammonium nitrate and dilute. Suggest what would be observed in this reaction. It's a mixture of ammonium nitrate and nitric acid. Now, ammonium nitrate is ammonium ions and nitrate ions. Nitric acid is H+1 and NO3 -1 ions. And he's added, it's a 2-mark question. So he's added calcium ammonium nitrate is formed when calcium carbonate is added to a mixture. So calcium carbonate is being added. The first part is it's got an acid. So the calcium carbonate would react with the nitric acid and it would form calcium nitrate. And water plus carbon dioxide. That's the first part. The carbon dioxide gas bubbles, effervescence will be seen. That's the first part. So the carbonate will get converted to carbon dioxide. And the solution will now have calcium nitrate. Okay, so it's going to have the reaction over. So it's going to have calcium nitrate in the solution. And that's it. So the product that's going to be formed is going to be calcium, ammonium, and nitrate. We go calcium carbonate in the opposite reaction again, and this was formed. And finally, what will so what's the observation? It's just effervescence. First, 2 observations. One is the solid dissolves. And 2 is effervescence produced. Okay, calcium nitrate decomposes at a higher temperature than calcium ammonium nitrate. Write an equation for the decomposition. It's the same typical equation. Okay, NO2 produce hoga plus half O2. चलो ये है इसमें और first second question. So this one is about writing the electronic configuration of Fe2 plus ions. It's 26 electrons, so that's 1s2, 2s2, 2p6, 3s2, 3p6. उसके बाद क्या आता है 4s2 और फिर 3d आता है. 3d is so 26 would be 3d6, and it's 2 plus, so that means these 2 electrons are gone, the outer shell electrons. S2, assuming that S2 minus 1 की oxidation number figure out करना है. So S2 with 2 minus charge. How do you figure out the oxidation number? You're going to take sulfur as X, and there are 2 of them, so it's going to be 2X. And the total charge on the 2 sulfurs is minus 2. So X comes out to be equal to minus 1. So 1 sulfur is going to be minus 1, which is why 2 sulfurs are going to have minus 2 charge. Describe the metallic bonding in gold. So diagram, draw kind of what's metallic bonding. There would be a bunch of metal atoms. Positively charged. With free moving delocalized electrons. So it's known as a giant, but the wording has to be, you have to be very careful with the wording. It's a giant metallic lattice. It's a giant metallic lattice in which you have regular arrangement of positive metal ions in a sea of free moving electrons. चलो ठीक है, ये कंटिन्यू करते हैं. पेपर ऑलमोस्ट कंप्लीट हो गया. ठीक है, वी ऑलमोस्ट डन. दिस वाज द इजी पेपर. ठीक है, नेक्स्ट टाइम कुछ और करते हैं. ये और पेपर करते हैं थोड़ा मुश्किल. ठीक है, वो मैं करता हूँ, ऑल्सो मैं करता हूँ. चले, ओके ठीक है.
Okay, sir. Allah Hafiz.